All right, so you want some extra practice on sequences. We have arithmetic sequences and geometric sequences. And I'm going to talk about both of those plus the explicit form and the recursive form. And then also the alternative form with the a sub 1 stuff and a sub n stuff. Not a big difference, just need to show you that because that's really where this is heading. Here we go. For the arithmetic sequence, you find that the common difference, okay, which is the increment goes up by 4 plus 4 each time. So if you notice it goes up by the same amount every time when you're adding, that's called arithmetic. So the way we do this, we do, in the past we did f of x or y equals. Okay, so maybe I'll do all three. Y equals up by 4, so like the slope will be 4x plus b. Well, b is like the y-intercept. The y-intercept is going back a spot, finding the 0th term. So if I go back a spot, I get plus 0. So in this case, and then we converted to this to f of x form. Okay, and then now with sequences, because this is a line going through 0, it's actually a line, turn that straight, up 4 over 1, okay, because that's the slope, and it's a line. F of x, same thing, it's a line. With sequences, we don't have this whole line here. We only have part of it. We only have 1. The first term is 4. The second term is 8. The third term is 12. We don't have a line connecting these, and this goes on forever. Okay, and we don't have the 0th. The 0th would be here, but we don't put a dot there because it's not in the sequence. This is a discrete situation. Not continuous. If I connected it, it would be continuous. Discrete, like separate points. All right, so with all that in mind, we put it in the form t of n to signify, to let us know that it's a sequence and not just a regular function. And then we have our increment, so our 4n plus our 0, and the 4n's from the difference, not from that 4, because it goes up by 4. And then our 0th term is plus 0, so you can just have the 4n. It's fine. Okay. Recursive. Recursive is based on looking at the previous term. It goes, I add 4 to the previous term, add 4 to the previous term. So this is what we're going to do. We're going to write it this way with plus 1. You could also just do t of n. Like most places, you'll see this. And then is the previous term. Well, previous to n plus 1 is just n. Okay. Previous over here would be n minus 1. Again, we're not doing this in this book, in our CPM book. We're not doing this way, but I'm just going to show you both for this first time, and I won't show it to you again. And then what do I do with this previous term? I add 4. What do I do with this previous term? I add 4. So either one of these is fine. You're going to see it this way more often. Now, the one thing you need to know about recursive formulas is we're not done, because there's lots of formulas that has 4 adding to, or sequences that add 4 to the previous formula or previous term. Like I could have 6, 10, 14. That's adding 4, add 4, add 4, same formula. Well, what if it was 7, 11, 15? Same formula. Get the idea? So we have to be more specific than just this, adding 4 to the previous term. So what do? We give one of the terms. So that's where we put the semicolon, and typically we'll give the first term. Sometimes they'll give the 0th for some reason. But the first term is 4. Okay, that's what we're looking for the recursive. Okay, I could put, again, t of 0 equals, in this case, 0. I can go back to the 0th term if I want. But let's just go with t of 1. All right, then we'll go to, I won't do all of these, but let's do, I don't know, I guess we just do 34. This goes up by 7. This goes up by 7. Well, you know what? Let's do the next one because it goes down. That's more fun. This goes down by 12. This goes down by 12. So you can see the difference. So explicitly, t of n equals the increment is negative 12 times n. And then the previous term, so add 12, 27, 37, 39. So that's the explicit formula. The recursive then, take the t of n plus 1, take the previous term, which happens to be t of n, because it's 1 less than this, And then what am I doing each time? I'm subtracting 12. And then give a term number. Let's say the first term. First term is 27 in this case. Pretty straightforward. Okay. I'm going to go on. If you want to try these, the answers for these are in your on your cpm.org on the website in the extra practice problems, because I just copied these from there. Extra practice. I don't know if it's under the students or under the parents, but it's extra practice. And then they have all the answers for these also. There's more problems than just these. Now let's go to the geometric sequences. If you the one we were just doing a second ago was like listing them this way. In fact, let's just go ahead and do this. And I'll go back to the other ones in a minute. If you go here and you try to say, well, okay, I'm adding 8. I'm adding 8. Oh, nope, I'm not adding 8. So it's not arithmetic. And then you say, well, can I multiply times something? Times 5. Times 5. Oh, so if you are multiplying by the same thing, then it is geometric. Okay. In geometric, we do the same kind of thing. T of n. Think of the 0th, just like with our adding. Actually, let's do the multiplier first, because that's what we did first too. So we'll do times 5. So we just do, it's times 5, times 5, times 5, like that. You keep multiplying times 5. Well, it's different with geometric. You have to go 5 to the power of n, not 5 times n. If it's 5 times n, that's actually arithmetic. 5 to the power n. Because it's whatever your 2 is, times 5, times 5, times 5, times 5. You keep multiplying 5 times itself. How many times? Well, n times. If it stops here, it would be 2 times. If it stops here, it would be 3 times. Get the idea? And then we have to multiply times something. Okay. We multiply by the 0th term, just like we do in our arithmetic sequence. So we have to back up a spot. So divide by 5 to get the previous spot. So 2 divided by 5, I guess if you want to write a decimal, you could, but I'm just going to write 2/5, like 2 divided by 5. And then times 5n. There's my explicit formula. Okay. If you, we'll just leave it at that. I don't want to make it more complicated. And then let's go recursive. Recursive then, t of n plus 1 equals taking each term, so t of n, then I'm going to multiply it times 5. Because each time is times 5. And that's it. Give me one of the term numbers. So let's say the first one is 2. So we have a place to start. So recursive, to me, seems easier. The notation looks scarier, but it's easier to understand because it's just, oh, times 5. This is kind of confusing for most kids. Okay. Now I need to talk to you about the alternative format of this. Instead of t of n plus 1, they have a of n plus 1 this way. A sub n plus 1 equals a sub n, instead of t of n, a sub n times 5. Semicolon, a of 1. So the first term is 2. And like I said in class, this is what I learned. This is where we're heading with all this. I'm guessing they did this in this book, this form, just to kind of make an easier transition between f of x notation and then this stuff, because it's very similar. And then they're taking this and going to convert it to this, because this is how you're going to see this notation probably more often. Okay, in Algebra 2 especially, and in college, you'll see this stuff. All right, let's do 52. Let's go green. All right, explicit. And if you want to try this on your own, go ahead and do it, and then pause it and see what I have to say. T of n equals the multiplier here. I'm going times 1/4. Times 1/4. You could do divide by 4. It's the same thing, but we're always going to write these times. So multiply times 1/4. So it's 1/4, and it keeps repeating 1/4, 1/4, 1/4. That's why we put the power of n there. And then the 0th term is actually 64. So there's my explicit format. Now I'm just going to throw this out there. I don't want this to confuse you, but there's other ways to doing these. You know, I could do 1/4, and then let's say you wanted to start with 16. Okay. Well, in this case, if it's 16, like the first term, well then up here you can't have n, because if I plug in, let's say the first term, I want the first term right here. Well, 1 1/4 times 1, or to the first power, is 1/4. 16 times a fourth is 4. Well, that gives you the second one. So what we have to do with this thing is go n minus 1. In other words, to plug in 1 to find the first term, I could use this formula. N minus 1 is 1. I'm sorry, 1 minus 1 is 0. 1/4 to the 0th power is 1. So 16 times 1 is 16. So this is another form or another way of looking at the same formula. Instead of doing the 0th, you could actually put the first term in there. Okay, and then just this would change this to an n minus 1. I will try to avoid this. I just need to throw it out there so if you do see it in assignments, you know what that's talking about. In the case I will normally, if this is just a regular n, that's going to be the 0th. Okay, and recursive for 52. So the next term, t of n plus 1, is the same. We take the previous term, t of n. That's lovely. All right, bell rang. And multiply times 1/4. And then give me a term number. So see, the first term is 16. Okay. Hope you can hear the music in the background. All right, and then I'm gonna go back to this quickly, just in case you see these. These are actually easier than the ones we just did. But if they say find the first terms of each sequence, just plug in 1 for n, right? Because 1 means first term. So if n is 1, you get the first term. 3 to the first is 3. 3 times negative 3 is negative 9. So that's the first term. If I have 2, 3 squared is 9. 9 times negative 3 is negative 27. If I plug in 3, 3 cubed is 27. 27 times negative 3 is negative 81. And keep doing those. Now, if you notice this, the multiplier is 3 times 3. There's our multiplier right there, times 3. This term right here is the 0th term. So it makes sense from what we just did a second ago. Okay, so if you want to do these quicker, you can just start with the 0th term, 6. Oh, it's not going to work this way because of n minus 1 in this particular example. But if they had a 1 here. So we actually have to write this one out if we're going to do this. I was going to say you could do the first one, we could have done quicker by just saying that's the 0th term. I can multiply times 3 and start with negative 9. And then the multiplier is times 3. So going times 3 times 3 times 3. All right, hope that helps. Good luck.